Hi everyone. Today we're going to study definition, terms, and common ratio of a geometric sequence. Let us define geometric sequence. A geometric sequence is one in which any term divided by the previous term is a constant. This constant is called the common ratio, denoted by R, of the sequence. If a sub 1 is the initial term of a geometric sequence and R is the common ratio, the sequence will be like this. The first term is a sub 1. The next term, we will multiply a sub 1 by the common ratio. So we have here a sub 1 times R. For the third term, we will multiply the second term with the common ratio. That's why you see here a sub 1 times R squared. For the fourth term, this third term is again multiplied to the common ratio. So we have a sub 1 R cubed. And this process will continue on and on. So we say that this is our a sub 1, the first term. This is our a sub 2, the second term. This is our a sub 3, the third term. And this is our a sub 4, the fourth term, so on and so forth. Let's have example 1. Check whether the following sequences are geometric. If so, state the common ratio. We have examples A and B here. For example A, the first term is 1, second term is 2, third term is 4, fourth term is 8, fifth term is 16. For us to know if this is a geometric sequence, we must check each pair of consecutive terms. They must have a common ratio. The formula for common ratio R is this: a sub n, this is any term, divided by the preceding term. Let us take two consecutive terms. Let's say R equals a sub 2 over a sub 1. So it is here. Substituting these values, we have now 2 over 1. And we have 2. This is the ratio of a sub 2 and a sub 1. Let's take another pair. Let's say a sub 3 over a sub 2. And this is 4 over 2, which is also equal to 2. Let us take another pair, a sub 4 over a sub 3. That is 8 over 4. And simplifying, this is also equal to 2. Let's have the last pair, the a sub 5 over a sub 4. That is 16 over 8, which is also equal to 2. We can see here that the ratio is common. So we can say that this is a geometric sequence and the ratio, or I should say the common ratio, is 2. Let us have example B. The first term is 48, second term is 12, third term is 4, fourth term is 2. Let us take the first pair, R equals a sub 2 over a sub 1. That is 12 over 48. Simplifying this fraction, we have 1 over 4. Let's take another pair, the a sub 3 over a sub 2. and that is equal to 4 over 12. Simplifying this is equal to 1 over 3. Let's take another pair, the a sub 4 over a sub 3. That is 2 over 4. And the lowest term is 1 over 2. We can see here that the ratio between two consecutive terms are not equal. So we say that this is not a geometric sequence. This is our final answer. Let us have example 2. List the first 4 terms of the geometric sequence with a sub 1 equals 5 and r equals negative 2. Here we have the general picture of a geometric sequence with first 4 terms listed as a sub 1, a sub 2, a sub 3, a sub 4. Now, for our answer, the first term as 5 is now listed in here. For us to find the next term, or the a sub 2, we will multiply the term by r, or the common ratio, to get the next term. It means to say, the a sub 2 is equal to this number 5. The first term is multiplied to the common ratio negative 2. So that is 5 times negative 2 is negative 10. This value we will substitute in a sub 2. Now let us find a sub 3. Simply we will multiply this negative 10 to the negative 2, and that is positive 20. Let us substitute the value 20 for a sub 3. Now for a sub 4, we will multiply this a sub 3, which is 20, to negative 2, and we will have the negative 40. We will substitute this negative 40 in here. So we are now complete with our first 4 terms of the required geometric sequence. This is our final answer. Let's have example 3. List the first 5 terms of the geometric sequence with a sub 1 equals 400 and r equals 1/2. Here we have the first 5 terms of the geometric sequence from a sub 1 up to a sub 5. Since 400 is given as the first term, we may substitute now this value in here. Now let us find the next term, a sub 2. Again, we will multiply this 400 to the common ratio 1/2. So that is 400 times 1/2. That is equal to 200. We can now substitute this 200 for a sub 2. Next, the a sub 3 can be found by multiplying this 200 to the common ratio 1/2. And our answer is 100. Let us substitute this 100 to a sub 3. To get a sub 4, we will multiply this 100 to the common ratio. So that is 100 times 1/2 is 50. This 50 will take the place of our a sub 4 here. Now for a sub 5, 50 times 1/2, that is 25. And this 25 is the value for our a sub 5. We are able to list the first 5 terms of this geometric sequence. This is our final answer. Hi everyone. Today we're going to study general term of geometric sequence. Let us recall that a geometric sequence has a sub 1 as the first term with r as the common ratio and listed as like this. The first term is written plainly as a sub 1. The second term is the product of this a sub 1 and the common ratio. The third term is the product of this second term times the common ratio. So we see here, this is a sub 1 times r squared. For the fourth term, this is a product of this third term times common ratio. So we have a sub 1 times r cubed. To generalize, the general term, or we say nth term, of a geometric sequence is this. A sub n equals a sub 1 times r raised to power n minus 1. In this formula, we need the first term and the common ratio. Take note that this n here in the power is the same with the subscript of a. Let us have example 1. Find the general term of the following sequences. We have problems A and B. Let's begin with problem A. We have the first term 3, second term is 6, third term is 12, fourth term is 24. The general term formula is written here. We know that this formula requires the first term and the common ratio. We can simply get the first term in here, that is 3, and the common ratio, we will take the ratio of any two consecutive terms, like this 6 divided by 3, we will get 2. Or we can take another pair, this 12 divided by 6 is also 2. Or we can take this 24 divided by 12 is also 2. So the common ratio is 2. Substituting now these values to our formula, we have a sub n equals the a sub 1 is now 3 times the r, or the common ratio, now becomes 2 raised to the power n minus 1. So this is now our answer, and we will copy this below this problem A. Let us proceed with problem B. The first term is 2, second term is negative 4, third term is 8, fourth term is negative 16. Let us collect the first term, that is 2, and the common ratio is negative 2. Just to check, if we take this negative 4 divided by 2, that is negative 2. Or this 8 divided by negative 4 is negative 2. Or this negative 16 divided by 8 is negative 2. We can see here that the signs of our terms in here are alternating from positive to negative to positive to negative. That is what happened when our r, or the common ratio, is a negative number. Now, let us substitute these values to our general term formula. So we have a sub n equals, the first term is now 2, times our r is negative 2, that is raised to a power n minus 1. This is now our answer, and we will copy this below this problem B. This is now our final answers. Let's have example 2. Given a geometric sequence with a sub 1 equals 3 and a sub 4 equals 24, find a sub 2. We have our formula here, and we know to find a sub 2, we need to have the a sub 1, which is already here, but we don't have the common ratio. That's why we need to solve for r. Using the given, the a sub 4 equals 24, let us first write this a sub 4 with regard to our general term formula. It means the a sub 4 equals a sub 1 times the ratio raised to 4 minus 1. We will substitute this a sub 4 value as 24 and this a sub 1 as 3 respectively as given in our problem here. And for the r, that is raised to 4 minus 1 is 3. Let us divide this equation by 3 so that only r cubed on the right side remains. So this 24 divided by 3 gives 8, and this 3 r cubed divided by 3, only r cubed remains. So we can write r cubed equals 8. We want to get the value of r. Let us take cube root of both sides. So the answer for r is equal to 2. This is the common ratio. Now we are ready to get a sub 2, and this is equal to a sub 1 times r raised to 2 minus 1. And the power is simplified into 1. Let us now substitute the first term and the value of r that was derived here. So we have a sub 1 is 3 as given here, times the r is now 2 raised to power 1. So simplifying further, our a sub 2 is equal to 6. So this is our final answer. Let us have example 3. List the first 5 terms of a geometric sequence with a sub 6 equals 25 and a sub 8 equals 625. Here we have the 5 terms of a geometric sequence in general form. We have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Also, our general term formula is written here, a sub n equals a sub 1 times r raised to n minus 1. In this formula, we need the first term and the common ratio r. But these values are not given in the problem. So let us derive the first term and the r based on the given a sub 6 equals 25 and a sub 8 equals 625. Let us begin with a sub 6. Let us write this a sub 6 with respect to the general term formula. So we have a sub 6 equals a sub 1 times r raised to 6 minus 1. So 6 minus 1 is 5. And then let us substitute this value a sub 6 as 25. So we have now 25 equals a sub 1 times r raised to 5. Let us regard this as our equation 1. The next, our a sub 8. Let us write a sub 8 with regard to our general term formula. So we have a sub 8 equals a sub 1 times r raised to 8 minus 1. And this 8 minus 1 is simply 7. Let us now substitute this value 625 to our a sub 8. So we have now 625 equals a sub 1 times r raised to 7. And this is now regarded as equation 2. Our next step is to divide equation 2 by equation 1. So the left side will be 625 over 25 equals, the right side is a sub 1 times r raised to 7 all over a sub 1 times r raised to 5. Let us simplify both sides of the equation. This 625 divided by 25 will give 25. On the right side, we can cancel a sub 1 that is common in the numerator and in the denominator. And for the r, we will subtract the exponents as a rule of division of exponents with the same base. So this is 7 minus 5. So we have here r squared. And then find r. Let us take square root of both sides. So square root of 25 is 5. The square root of r squared is simply r. Or we can write r equals 5. So we have now this common ratio, which is 5. Let us substitute r equals 5 to equation 1 to get a sub 1, the first term. So we have this equation 1 is now written as 25 equals a sub 1 times r, which is now 5, raised to 5. Simplifying further, this 5 raised to 5 gives 3,125. Now let us solve for a sub 1. Let us divide this equation by the coefficient of a sub 1. That is 3,125. So this 25, if we divide by 3,125, it will form a fraction. While on the right side, if we divide this by 3,125, this coefficient will cancel. So we have a sub 1 equals the 25 over 3,125. If we reduce this to lowest term, meaning let us divide both numerator and denominator by 25. So we will get this 1 over 125. This value now is our a sub 1, the first term. So we can substitute this a sub 1 in here, in our first 5 terms of the geometric sequence. Now let us solve for a sub 2. Using our general term formula, we have a sub 2 equals a sub 1 times r raised to 2 minus 1. Let us substitute our values. The r and the a sub 1 are here. So we have now this a sub 1 is 1 over 125 times r is 5. We can cancel this 5 and 125 and we will have this 1 over 25. This is our a sub 2, the second term. We can substitute now this value in here. Next, let us find a sub 3. Using our general term formula, we have a sub 3 equals a sub 1 times r raised to 3 minus 1, or 2. And then let us substitute our values. The a sub 1, again that is the first term, is 1 over 125 times the r, which is 5, raised to 2. Simplifying further, this 5 square gives 25, and we can cancel this 25 with 125. So we will have 1 over 5. This is now our a sub 3. Let us substitute this value in here. Next, let us find a sub 4. Using our general term formula, the a sub 4 equals a sub 1 times r raised to 4 minus 1. And this 4 minus 1 is simply 3. Then, let us substitute the a sub 1, or the first term, and the common ratio. We have now 1 over 125 times 5 cubed. Simplifying this value, we have 125, which we can cancel with the denominator here. So the final answer, the a sub 4, equals 1. This value we will substitute in here. And the last term is a sub 5. Using our general term formula, this is equal to a sub 5 equals a sub 1 times r raised to 5 minus 1, which is equal to 4. Substituting our a sub 1 as 1 over 125, the common ratio of 5 is here, raised to 4. Simplifying this 5 raised to 4 is 625. Then we can cancel this 625 and the 125 here. That will give us 5. And this 5 we will substitute in here. So we are now complete with our first 5 terms of the required geometric sequence. This is our final answer. Hi everyone. Today we're going to study recursive formula of geometric sequence. A recursive formula allows us to find any term of a geometric sequence by using the previous term. Each term is the product of the common ratio and the previous term. The recursive formula for a geometric sequence with common ratio r and first term a sub 1 is this formula. A sub n, the general term, equals r times the previous term, which is a sub n minus 1. There is a condition that the n here, or the number of terms, must be greater or equal to 2. Let's have example 1. Write a recursive formula for the geometric sequence where the first term is this 100, second term 20, third term 4, fourth term 4 over 5. Let us write the recursive formula here. In the recursive formula, we simply find r, or the common ratio, and substitute in the formula, and that will be the final answer itself. So to get the r, we will take any two consecutive terms in our geometric sequence. Let's say we take a sub 2 over a sub 1, and that is 20 over 100. Using our calculator, we will have 0.2 as the R. Or let us check for other pair of consecutive terms. This time, let's have a sub 3 and a sub 2. So we have a sub 3 over a sub 2, and that will be 4 over 20. And this value is also 0.2. What about the fourth term and the third term? And that will be 4 over 5 all over 4. Let us flip this 4 in the denominator as 1 over 4 here. Then let us multiply the 4 over 5 and this 1 over 4. We can see here that we can cancel this number 4 in the numerator and the number 4 in the denominator. And we will have 1 over 5 left. And that value is also 0.2. So we can see here that the R is common for all the pairs. Now, using the value of R, we will substitute in our recursive formula. So we will have now a sub n equals 0.2 times the previous term denoted by a sub n minus 1. This is our final answer. Let's have example 2. Given a geometric sequence with a sub 1 equals 3 and a sub 4 equals 24, write its recursive formula. The recursive formula is here. And again, let us find R and substitute in the formula. In our problem, given is the first term and the a sub 4, the fourth term. Let us use the general term formula as a sub n equals a sub 1 times R raised to n minus 1. Given is a sub 4, and with respect to our general term formula, we may write a sub 4 equals a sub 1 times R raised to n minus 1, and this is 4 minus 1. And this 4 minus 1 is simply 3. Now, let us substitute the values a sub 4 and a sub 1 respectively. So we have now 24 equals 3 r cubed. And then let us solve for r. First, let us divide by 3 so that the coefficient will be cancelled out. So this 24 divided by 3 will give 8. And this 3 r cubed divided by 3 will give r cubed. Let us solve for r by taking the cube root of both sides. So the cube root of 8 will be 2, and the cube root of r cubed is simply r. So this is r equals 2. So we are able to find the value of the common ratio as 2. This value 2 is what we need in our recursive formula here. So let us substitute. So we have now a sub n equals 2 times the previous term a sub n minus 1. And this is our final answer. Let us have example 3. Given a geometric sequence with a sub 7 equals 100, this is the seventh term, and r, the common ratio, equals 0.25, find a sub 9, or the ninth term. For illustration, let us write 9 terms of the geometric sequence in general form, starting from a sub 1, a sub 2, a sub 3, up to a sub 6, followed by a sub 7. But since in our problem, given is the value of a sub 7 as 100, let us put it here. And then followed by a sub 8, and the last is a sub 9. And this a sub 9 is what we want in our problem here. Using our recursive formula, we can solve for a sub 8. And our a sub 8 is equal to r times a sub 8 minus 1. And this 8 minus 1 is 7. And take note, this a sub 7 is this value 100. Let us now substitute the values r and the a sub 7 in here. So we have now 0.25, that is our r, times the a sub 7, it is 100. And the product is 25. This is our a sub 8. Next is the a sub 9. With respect to our recursive formula, that is equal to a sub 9 equals r times a sub 9 minus 1. And this is a sub 8. This a sub 8 is the value 25 in here. Substituting the values now, the r is the common ratio, that is 0.25 times a sub 8, and this is the 25. The product here is 6.25. This is our a sub 9, and this is our final answer. Hi everyone. Today we're going to study sum of geometric sequence. First, let us define geometric series. If a sub 1, the first term, the second term will be a sub 1 times r. The third term is a sub 1 r squared. The fourth term is a sub 1 r cubed, up to the last term, a sub 1 r raised to n minus 1, is a geometric sequence where a sub 1 is the first term and r is the common ratio. Then the sum a sub 1 plus a sub 1 r plus a sub 1 r squared plus a sub 1 r cubed plus up to the last term a sub 1 r raised to n minus 1 is called geometric series. Let us now discuss formulas for geometric series. The first formula is for infinite geometric series. The formula is S sub infinity equals a sub 1 over the quantity 1 minus r. A sub 1 is the first term and r is the common ratio. There is one important note here, that the absolute value of r, the common ratio, must be less than 1. Letter B formula is for finite geometric series, and the formula is S sub n, that is equal to a sub 1 multiplied to the quantity 1 minus r raised to n. The n is the number of terms. all over the quantity 1 minus r. Let us have examples. Example 1. Calculate the sum of infinite terms of the sequence. The first term is 1. Second term is 1/3. Third term 1 over 9. And fourth term 1 over 27. So on and so forth. Because of the word infinite here, we are going to use the formula S sub infinity, that is equal to a sub 1 over 1 minus r. But take note that the absolute value of r must be less than 1. Let us now collect the required value for the formula. The first is a sub 1, the first term, and that is 1. Next is r, the common ratio, which is not readily given in the problem, but we can solve for r. We will take any two consecutive terms, putting them in a ratio, and this ratio must be common to all pairs of consecutive terms. Let's begin with r equals a sub 2 over a sub 1, and that is 1/3 all over 1, and this is equal to simply 1/3. Let us take another pair, that is a sub 3 over a sub 2, and this is equal to 1 over 9 all over 1/3. Let us show now that this is 1 over 9 times the inverted fraction 3 over 1. So we can cancel the 3 and the 9 down here, and this is also equal to 1 over 3. The last pair of consecutive terms is a sub 4 over a sub 3, and this is equal to 1 over 27 all over 1 over 9. So let us multiply this 1 over 27 into the inverted fraction 9 over 1. We can cancel this 9 and the 27, and the simplified form is also 1 over 3. We can see here that the ratios are common, and that is equal to 1 over 3. So we can write the absolute value of r is 1 over 3, and take note that this is less than 1. So we can use our formula here. And then let us write this value in our blank opposite the r on this side. Then let us start solving for s sub infinity. Substituting the values, this is now a sub 1 is now changed into 1. The r is now changed into 1/3. Let us simplify further. Let's begin with our denominator. This whole number 1 we will convert into a fraction that is with the same denominator with 1/3. So what we'll do is to multiply this 1 with 3 and put the answer in the numerator of the fraction here. All over, we will simply copy this denominator 3 in here. So we have this value 1 is equal to 3 over 3. And then we can see now that our denominator has difference of two fractions with same denominator. So we can simply operate in the numerators, and that is 3 minus 1, and that is 2 over 3. And then let us invert this 2 over 3 into 3 over 2 to be multiplied with the numerator 1. So 1 times 3 over 2 is simply 3 over 2, or we can write 1.5. This is our final answer. Let us have example 2. Find the sum of the first 10 terms of the sequence. First term is 2, second term 4, third term is 8, fourth term is 16, so on and so forth. Since we're going to find the first 10 terms, we will use this formula S sub n equals a sub 1 times the quantity 1 minus r raised to n all over 1 minus r. Let us list the required and given values. The first is S sub 10. This is the sum of first 10 terms that is required in the problem. Next is a sub 1, the first term, and that is 2. The r is not yet given. We will solve for that. And the n is the number of terms, and that is 10. So let us now solve for r using any two consecutive terms in our sequence. Let us also try to see if the r is common in any given consecutive pairs. Let's begin with a sub 2 over a sub 1. And this is equal to 4 over 2. And 4 over 2 is equal to 2. The next pair is a sub 3 over a sub 2. And this is equal to 8 over 4. And 8 over 4 is also 2. And the last pair is a sub 4 over a sub 3, which is equal to 16 over 8, which is also simplified into 2. We can see here that the ratios are common, and we are sure that this is a geometric sequence, and we can use our formula here. Also, let us copy this value in our blank here. So r is equal to 2. Now, let us begin with our solution for S sub 10. And using our formula here, let us substitute the values. So we have a sub 1 is now 2. And take note, the r, or the common ratio, is used twice. One in here, also in here. So we have 2 times the quantity 1 minus 2 raised to 10 all over 1 minus 2. Let us simplify this 2 raised to 10. Using our calculator, we have 1024. In the denominator, the 1 minus 2 is simply negative 1. Let us simplify further. These numbers inside the grouping symbol, 1 minus 1024, will be negative 1023. Let us get the product of this negative value and the number 2 outside. We will get this negative 2046. And we have negative divided by negative. The answer will be positive. And this is negative 1 in the denominator. So simply we can write this 2046 positive. This is our final answer as the sum of the first 10 terms of the given sequence. I hope you learned something from this video. See you again next time.